Let's consider this setup. We have block. Mass is 10 kg. And there's a block of plate. Mass 6 kg. Okay. There is no friction on the lower surface. This is smooth. ये जो surface है नीचे वाला smooth surface है, कोई friction नहीं है. लेकिन दोनों block के बीच में between the two blocks there is a friction and the friction coefficient is given by 0.6. It is same. We say static, kinetic दोनों same. Okay. और क्या करते हैं कि नीचे वाले पे force F लगाते हैं. To find out the acceleration of the two blocks in two cases. The first case, capital F को हम लेते हैं for example. और second case में capital F लेते हैं 120. Both these cases, we have to figure out the acceleration of the two blocks. Okay. सबसे पहले तो at least draw the FBD. अच्छा actually एक बात मैं बोल रहा था normally friction का direction अगर find करना है ना तो उसका technique क्या है? You assume for the moment there is no friction. अगर friction नहीं है तो क्या हो रहा है? जैसे यहाँ पे obviously यहाँ पे तो कोई friction नहीं होगा. इनके बीच में लेकिन friction force होगा. To find कि किस direction में होगा, that is I assume for a moment that friction है ही नहीं. What if there is no friction between them, 6 and 10 kg? अगर friction नहीं है दोनों के बीच में, तो अगर नीचे वाले को pull करेंगे तो क्या ऊपर वाला move करेगा? ठीक है, नीचे वाला तो actually ऊपर move क्यों करता है? उनके बीच interlockings होते हैं, तो नीचे वाले को move करने के लिए ऊपर वाला भी move करता है. But interlockings होंगे नहीं, क्यों move करेगा? So उस केस में तो if there is no friction between them and apply the force over here, then what will happen is this block will simply slide towards the right. ये वहीं का वहीं रहता है, है ना? Ground के रिस्पेक्ट में ये आगे जाएगा तो ये वहीं पर रहेगा. लेकिन अगर मैं इस ब्लॉक के रिस्पेक्ट में चेक करते तो क्या दिखाई देगा? क्योंकि मैं रिलेटिव मोशन चेक कर रहा हूँ. इस ब्लॉक के रिस्पेक्ट में किधर जाता है दिखाई देगा. ठीक है, isn't it? अब हम फ्रिक्शन को अगर स्विच ऑन करेंगे तो फ्रिक्शन उस मोशन को रिवर्स नहीं कर सकता. क्या मतलब कि अभी भी टेंडेंसी इस ब्लॉक का पीछे ही जाने को इसके रिस्पेक्ट ग्राउंड के रिस्पेक्ट में नहीं. ठीक है, with respect to this block, the block 6 kg will still have a tendency to go backwards and friction will oppose that tendency. इस कारण से इसमें फ्रिक्शन ऐड करेगा सामने अपर ब्लॉक, लोअर ब्लॉक पे इंसर्ट कर. समझे? तो ना draw that is the FBD. Way that you draw the FBD is to first look at the long range force and look at the contact force. Long range force obviously gravity over, which can act without touching. So look at the contact forces. हर contact के लिए हम कितने force arise करते हैं. So idea is मैंने बोला कि basically जैसे हम लोग 10 kg को लेते हैं, 10 kg block. Let's call this as capital N. This one is small n. 10 kg is small n, 10 kg capital N. So for capital N, we draw the FBD. Obviously, with the long range force, the gravity. Long range is the gravity. It can act without contact. Fine. Look at the contact forces. So, how many contacts capital M has with external objects? Capital M का कितने contacts? एक यहाँ पे contact है, एक यहाँ पे contact है और एक यहाँ पे contact. 3 contacts. हर contact से forces count करें. यहाँ पे surface smooth है, तो एक ही force appear करेगा. Normal. That is the force of normal reaction. Let's call it as N, which the ground is exerting on the 10 kg block. है ना? Ground उसके ऊपर push कर रहा है 10 kg block. ये contact पे कितना force होगा? इस वाले पे है, क्योंकि हम लगा रहे हैं external agent. What about this contact? At this contact, हम two forces equal because of friction here. What is the force of friction? I just said that small f the friction acts on 6 kg block in the forward friction. 6 kg block नीचे वाले पे पीछे लग जाएगा. And there's one more force. this 6 kg is going to push a 10 kg block down. That force I'm going to call as N prime. N prime is the force which the 6 kg block is exerting on 10 kg. Okay. This is the FBD of capital M. What about small m? Small m, if I consider FBD. Again, we have long range force, gravity pulling it down. Then we have the contact force. कितना contact? एक ही contact है. Clear बात. यहाँ से जो भी force arise होने से पहले वही force होंगे opposite direction. इस contact से तो ये force था F और एक N prime था. अभी इनका direction उल्टा हो जाएगा. F सामने end करेगा और N prime ऊपर end करेगा. This is always force we have. There is no other force. है ना? Right. Now to clear up the acceleration blocks. First of all, we do not know whether they are going to slip or not. है ना? हमें तो ये बात नहीं पता कि वो लोग स्लिप करेंगे कि नहीं करेंगे. I do not know. अगर वो स्लिप करें तो पता है कि जैसे कि हम नीचे वाले को पुल कर रहे हैं और दो पॉसिबिलिटी ऐसा होता है कि दोनों साथ मूव करें या फिर अलग अलग स्लिप करेगा. है ना? राइट नाउ हमें नहीं मालूम तो स्लिप कर रहे कि नहीं कर रहे. तो करने का तरीका क्या है? We start by assuming that they move together. मतलब पहले हम assume कर लेंगे कि दोनों डायरेक्शन सेम. ठीक है? हम ऐसा assume कर लेते हैं. Because I do not know for sure whether these two blocks will have relative motion or not. Right. So what I do is I start by assuming that they do move together. मतलब कि slipping नहीं हो रहा. अगर slipping नहीं हो रहा तो मतलब एक साथ मूव करेंगे. So assume there is no slipping. If I assume there is no slipping, then the common acceleration can be determined. The common acceleration is called as A. That will be the क्योंकि तो एक साथ मूव कर रहे हैं तो I can create a single block. है ना? So that will come F by M plus N. So then I will take a 60 Newton force for example. तो नहीं दिख रहा है. Either which part you are unable to see. Common acceleration in the first case will be how much? The force is 60 Newton. The common acceleration becomes F by M plus M, which is 60 Newton by 16 kg. है ना? That will be roughly what? Will be 30 by 8. 15 में force divide कर सकते हैं ना? 80 by 8. So that will be around 312 then 3.75. ये हमारा assumption है. Now, what I notice, first of all, notice that this acceleration, small m का अगर रेडियस चेक करते हैं, small m के लिए तो एक ही horizontal force है, that is in the forward direction. Friction. Small m को ये acceleration कौन provide करेगा? Friction point. So I could write down there for the friction small f as, because that is m into e. Newton's second law says that this force F must be mass into acceleration. So basically क्या होगा? E छोटे वाले 6 kg block के लिए m into a should give us net horizontal force, which is F, small f. Therefore, I can find the friction force. F is nothing but small f into a, that is to say 6 into 2 by 4. Right? So giving us how much? That is giving us 45 by 2, 2.5 Newton. 45 by 2 is what is up, isn't it? Now I need to check whether the friction can provide as much force or not. What I notice is that the maximum friction between them, if I consider, what about the maximum friction? At this contact, first of all, notice that n prime is a normal reaction to this contact. This contact can normal is n prime है. और जो भी छोटा block जो vertical is no acceleration. I therefore have n prime equal to mg because there is no vertical acceleration. And therefore F max, if I consider, that would be u times n prime. That's maximum friction, which friction can provide the maximum value. How much is that? U is 0.6 and n prime is mg. M is 6, g is 10. So I get 6g, which is 36. The maximum friction it can provide is 36. Maximum force friction provide कर सकता है 36 न्यूटन है. तो PL कितना required है? 12.5. Definitely friction is enough to provide. इसका मतलब यहाँ friction का value 22.5 न्यूटन नहीं होगा और दोनों साथ में मूव करेंगे. ठीक है? In this case, therefore, because the friction is able to provide that much of force which is required, provide that much of acceleration, therefore, the two blocks will simply move together. And the common acceleration is this, and the friction force will be 22.5 newtons. There is no need for friction to go to the maximum value. Okay.